So today I'm going to talk about the gradient, although in this example I'm going to call it the slope, but gradient and slope mean the same thing. Okay? So here we have a form of our equation, y equals kx plus m. Now in your textbook it says y equals kx plus c, but c and m, same letter, doesn't really matter which one you use. Okay? So each one of those has, something special about it in terms of linear equations. So for example, if we have y equals 2x plus 1, just like we did last time, we pick values for x, so in this case 0, 1, 4, 8, and then we solve for our values for y. So when x is 0, 0 plus 1 is 1. If x is 1 here, then 2 times 1 is 2, plus 1 is 3. If x is 4, then it's 8 plus 1, which is 9, and so on. Right? So we put in those values for x and get our values for y. Okay, so just like what we did before. And then, of course, we can use these points, put 2 points on our graph, and then we have a line. Okay? Now, so I'll take the example I did here, so y equals 2x plus 1. I put up a few of the points, and then I just connected them, and there we have our line. So this is exactly what we did last time. Okay, and like I said, you only need 2 points to draw the line. Any 2 points will do. So nothing we haven't seen already. But the parts of this equation, so like we started with, the 2 and the 1 there, I never really described what those mean or how another way in which you can use them to graph your lines. Okay? So are there any questions so far? This is just what we did last time. Okay. So then, when we talked about last class about solving an equation, we said how with x and y there's many different answers you could get. Okay? So this line actually shows the relationship between x and y, and it shows you all of the solutions to x and y. So if I go back here, every point on this line is a solution to this equation. So every single point is a solution to that equation that we have. Okay? So here, now, we'll talk about what those numbers, or in this case letters, actually mean. So k represents the slope, which as I said is also the gradient. Because in your book, it will ask you to find the gradient of these lines. Okay? It's the same thing as slope. And m there, or in your textbook it's c, is the y-intercept. So if you understand how the slope and y-intercept work, graphing actually becomes quite easy. There's no need to make a table of values. You can easily get 2 points, and it's a lot quicker. But first, we have to understand what each of these things mean. So let this thing load, and I'm just going to show you. So here's some examples with the y-intercept and how it changes. So let's say, for example, I have y equals x. We'll just say y equals x for now. Okay, so we have that line, and you can see right now it passes through 0. So we call that the origin, if you don't already know that. Okay? So right now it passes through the origin. But if I take that same equation and I go plus 1, that's a plus sign. You just can't. It's harder to see on the board, but it is a plus sign. You'll notice that instead of at 0 now, my line is basically up 1 step. Right? I've moved it up 1. Or if I say, I'll go down here, say y equals x plus 2. Whoops. 2. Okay? So instead of 1 here, it now passes through 2. So that value at the end, the y-intercept, basically tells you where on the y-axis, so the vertical axis here, where your line crosses. So when there was nothing there, well, I might as well just add that one in too. So when you have y equals x, so there's no y-intercept, it passes through 0. Because the y-intercept is 0, so we just don't write it in. When you have plus 1, it crosses at 1. When we had plus 2, crossed at 2. Right? Make sense? So that's what the y-intercept. So that value that you're adding or subtracting is where it shows up on your y-axis. So just to show you, if I put minus 2, it's now negative 2. Right? So that's how that changes. So now, let's take away those two, and we'll start with this one here. So we have y equals y equals x plus 1. So I'm going to change that to 2x. So you'll notice my line still passes through the same point on the y-intercept, right, on the y-axis, but now my line is steep. It rises quicker, right? Because if I just have y equals x plus 1 again, you'll notice this one is much more steep than the other one, okay? That's what the slope is, so that k value. That k value basically tells you how steep your line is going to be. So if I have y equals 4x, right, it's much more steep than the other one. If I change that to, say, 8, it goes up much quicker. But it also works in the other way. So if I put 0.5, it's now more flat, right? Or if I put 0.1, it's a lot more flat than the other ones. Now, what happens if I put a negative sign in front of my slope? Any ideas? Yeah. It will go down instead of up. So if it's negative, your slope is going down. If it's positive, your slope is going up. Good? Yeah. Okay, so we understand our slope and our y-intercept. So this here is how we describe slope, I guess, in words. So this triangle here is what we call delta. So this is delta y over delta x.
Alpha.
Well, we don't deal with alpha yet. So delta y means the change in y. So how far up or down we went in the y direction. So change in y over change in x, or up-down change versus right-left change, or my personal favorite, rise over run. Because rise over run is a lot easier to remember, I think. So rise, basically how far up or down you go. Run, how far, well, in this case, to the right you go. So here, I know it's tough to see, so I will fill in these points. This point here is 0, 1, and this point here is 1, 3. Looks like. Oops. 1, 3. Okay? So I'm going to use those 2 points to find the slope of that line. So this is how it works. I start at my first point, and I want to look to see where the y goes. So the y started at 1, and then I went up to y equals 3. So from 1 to 3, I went up 2 points, 2 spots, or however you want to say it. I went up 2, right, from 1 to 3. Then I look at my x. My x here started at 0, and I went over to x equals 1. So I went from 0 to 1, so my x increase is 1. Okay. So to use these words here, the change in y is 2, change in x is 1. So I put y over my x. So So my slope for that line would be 2.
3 equals 2 equals 2.
Make sense? Haven't lost any of you? Good. So again, this one, same example, just now down instead of up. So here, my y went from 1 to 0. So going from 1 to 0, I subtracted 1. So that's why it's a negative 1 here. And then my my x went from 0 to 2. So I added 2. So I end up with negative 1 over 2. Now, one way to help you is always have x be positive. So for x, always go from left to right. Have y be the one where you either go up or down. That way you know whether your slope is positive or negative. So keep x always positive and only have y be negative if you have to go down. It just makes it easier, so you don't try to get confused going from right to left instead and confusing what your numbers should be. Okay, so we know how to find slope. Easy enough, right? Now, before I do that, I'm going to show you an example where you don't actually have the points on the graph. So let's say I give you just 2 points. Say 1, 4, and 3, 7, for example. Those are 2 points on my line, but I don't actually have the graph itself, right? I don't have a line there, just 2 points. So if you want to find the slope, right, change in y over change in x, this is what you could do. You take your y value from this point, remember x first, y second, which is 7, and subtract the y value from the first point. Then I take my x value from this point and subtract my x value from that point, which gives me 3 over 2. So that's just an example where you can solve for your slope without having the actual line in front of you, which will be useful later. Let's just make sure I get to this. Okay. So now I'm going to show you how to use slope and y-intercept to graph equations, so without drawing a table of values. Okay? So whenever you have an equation in this form, so y equals mx plus b, should I just use k? Or k, kx plus m, here we go. You always have 1 point right away. The first point you always have is your y-intercept, okay? Which is this one here. So right away, you can put one of your points. So the y-intercept of this one is plus 2. So if y equals plus 2, I have 1 point. Done. Now if you want to find your second point, you look at the slope, or gradient of your line. So if there's nothing in front of x, if x is by itself, the slope is understood to be 1. Right? Makes sense? There's usually a 1 in front of there. So if my slope is 1, then if I were to write it as rise over run, like we had before, 1 would just be 1 over 1, right? Because 1 divided by 1 is still 1. So that's what I use to get my second point. Go up 1, over 1. So I start at my x-intercept, and I go over 1 here, up 1 here, and there's my second point. And then I can just use those and draw a line, which will be about there, roughly. Try to get it through the points as best I can. There we go. So there's my line. So you put your your y-intercept first, put that point. Then you use your slope to find your next point. Then connect the dots. So this one here, where's my first point going to be?
To negative.
Where?
Oh, y.
On the y-intercept, -2. Okay. And then where's my next point going to be?
But you said we should keep the x negative. Positive.
Yes, with this, rise over run. So this will always be positive, this will be negative. So,
We divided by.
if my slope is -2, how can I write that as a fraction for rise over run? For my slope. How can I write -2 as a fraction? -2/1. Exactly. If your slope is a whole number, it's always just going to be that number over 1. You can just write it that way. So our k value is just -2/1. So if this is my first point, where's my next point going to be?
You go 1 down and 2 over.
2 down, 1 over. Rise over run. So this is the change in y, which is your vertical. This is your change in x, which is horizontal. So I go down 2 over 1. So my next point is at 1, -4. And then I do my best to graph my line. Should be something like this. That's close. Yeah, we'll just leave that one that way. And then there's my line. So once you get used to that, graphing lines, at least linear equations like this, becomes a very simple task. Just put one point, count up or down so many over a couple, draw another, connect the line. No table of values, none of that. So try this last one. So y equals 2 over 3x plus 1.
Do we like?
Need more graph paper? There's some around here. I need to print off some more. Oops. Dropped this. I'm going to let that catch up.